So, hello everyone, this is Sunil Pal, and today we are going to learn one lab experiment which is basically Inviscid and compressible flow through the CD nozzle. Okay, so let's start the experiment. Click the 2D and double press and start. It takes a little bit time. Okay, so we have this. Now basically first we are going to import the mesh file. Okay, this is basically 2D file. Now basically the problem is we have a one CD nozzle, and we know that the CD nozzle is basically used in rockets. So its one end is basically at the combustion side, this side na, at the combustion chamber side, and this one is at the ambient side. Okay, that means the atmospheric condition side. uh, so we have given some data for the initial conditions or for the inlet side, and also we have some data for the ambient side. So let's do some this problem. Okay, so first check it, scale it. So we have to just see that the yields must be in meters. Okay, so yeah, it is in by default it's in meter, so close it and display. If you want to see the edges, so you can click here and display, so you can see the outlet side. Okay, now we are going to set some models because the flow inside is turbulent, so we are using capsule model. Okay, now materials. So we are considering here that the ideal gas is flowing through this nozzle, CD nozzles. So just choose here idle gas. Again we have the property of the idle gas also. You can see here, change and create, and close this window. In cell zone conditions, we have to tell that this inside this CD nozzles idle gas is flowing. Okay, so for this we have to just click here and edit. Okay, and apply this, apply here and close it. After that we have to set the boundary conditions. So now we have the inlet. Okay, we have the inlet this, and we have given some data for this, so let's use those data. So the total gauge pressure we have is 22 and 40 Pascal. The Pascal. Okay, it's about of 2,10,000 Pascal. And change here as intensity and hydraulic diameter. Hydraulic diameter means the inlet diameter if we are using basically the inlet conditions. Okay, and intensity is a turbulent intensity, so it is about of 1%, and the diameter of inlet is basically about of 0.12 meter, and apply. Okay, close this panel. For outlet, okay, so set the gauge pressure as 1 lakh Pascal. Okay, yeah. Okay, and now again here change that as intensity and hydraulic diameter. So intensity again we have 1%, but the diameter is, as you can see, the outside diameter is somewhat bigger than the when we compare with the inlet. Okay, so it's about of 0.24 meter. Apply and close. Now we have to set the operating conditions. So inside basically when we consider the initial, so we set as operating condition 0. Okay, okay, and one thing I have forgot, uh, it must be of axisymmetric. Okay, because we are considering the half part of this nozzle. Okay, so here it is necessary to check this axisymmetric. Okay, now after that let's go on to the methods. So remain these values as by default. Okay. Now controls. And monitors. So if you want to increase its convergence criteria, so you can increase from here. Okay, by increasing the value of 0. Okay, but we are not changing actually, so just left the thing as. And okay, monitors initialization. Okay, so let's do initialization from inlet. Okay, initialized. Now we have to run this calculation part. So the number of iteration is about of 2000, and calculate this. It takes a little bit time to converge this. Okay. As you can see here, the energies line is basically continuously going down, so it is okay. Okay, and the conduit is all at the top side, so it is also acceptable. Okay, so both the things is going in a good way. Okay, so our solution is converged, and the number of iterations basically is about of 635. Okay, so in 635 iterations we have our solution is converged. And now let's plot some vector plot. Okay, so go on to the graphics, sorry, select vectors. Okay, and change style to arrow. Okay, and save and display. So you can see on your graphic window we have the vector something like this. Okay, and now you can see, if you zoom in, you can see there is basically arrow which shows that the idle gas is flowing from this combustion chamber side to ambient side. Okay, now close it. Okay, and plot contours for pressure. Okay, so now save and display, and you will have this. Okay, now basically what we are going to do, we are just going to change the models as Inviscid, sorry. And yeah, we have here. Okay, so we are considering this time that we have the viscous flow inside this nozzle. Okay, initialize if you want to do. Okay, just do the initialize button again, and run the calculation for 1000 number of iterations, and calculate. So as you can see here, basically the graph that we are going to um, plot here, that we have plotted here, basically is acceptable, and we require this type of graph only. Okay. Okay, now the calculation complete may be on yeah, on 111 iterations the solution is converged. Okay, so now again plots, vectors or contours. Okay, so in graphics, contour. Okay, save and display. So you'll have this. So if you want to see basically the complete nozzles, okay, so you can do some things like go on view. Okay, click the view button. Okay, and click this axis. You can see the complete nozzles from here. Okay, so this from my side, and thank you.